So please, as much as possible, please let's keep quiet, please. They just want to stress me this morning, and I'm not ready for the stress. So there's ink. Give me the money. So please, nobody should stand. There are 6 spaces at the front. Join them on that seat where the Elijah is. Sit in 2-in-1. Oh yeah, be fast. Come and join them here. I just properly see you join them. Is that one of the longer chairs? Eh? Oh yeah, come and sit here. So please, you can see that there is no mic, and I have to write on the board, so please listen. In the last class, I explained Kirchoff's law, or Kirchoff's law. So the first law, we call it the law of conservation of energy. Law of conservation of charges. So the second law, I explained the second law. So to remind you of Kirchoff's first law, there was a question like this to JAMB. So everybody should quickly determine the current there and tell me your answer, so I can explain Kirchoff's second law. Oh yeah, be fast. So what's the current in what I've drawn there? So one is 2 ampere, 1 ampere, 3 ampere, 2.5 ampere, 6 ampere, and you have to calculate the last one. So what's the answer? Minus 3.5. So according to Kirchoff's, the total current going in will be equal to the total current coming out. Abi? So in this case now, the arrows here shows the ones going in, right? And this shows the one coming out. So which means that this guy plus this guy plus this guy minus this guy, because it's going out, Sabi, minus this guy plus this guy equal to 0, right? So if you do your maths, that's 8, Sabi. So x plus 8, 2 plus 6, okay, there's 1 here. 9 minus 5.5, Abi. So that means x plus 3.5 is equal to 0. So x is equal to minus. Forget about the sign. It can be, if they didn't connect the circuits very well. But it's because I just gave you all those values so far. So now let's define Kirchoff's second law. You all understand what I did here now? So Kirchoff's second law, we call it loop law, also known as loop law. Loop, L-O-O-P, also known as loop law or voltage law. Loop law or voltage law. States that the sum of all the voltages in a loop, the sum of all the voltages in a loop is equal to 0. Is equal to 0. Is equal to 0. Putting directions into consideration, the sum of all the voltages in a loop is equal to 0. Putting directions into consideration, the sum of all the voltages in a loop is equal to 0. Putting directions into consideration. So what that is saying is that sum of voltages is equal to 0. So in your exam, you can see that, like the way they've always been asking, you don't see most of these questions in your past questions, but JAMB asks them now. They ask them. I have seen them before. So the sum of the voltages will be equal to 0 in a loop. I will explain it to you. But in your JAMB question, they might just tell you that which of the following is second law of Kirchoff's. Then summation I equals 0. B summation V equals 0. Do you get that? So for second law, it will be summation V equals 0. But for first law, it's going to be summation I equals 0. Do you get that, my point? So now, I'm just going to start from a very simple circuit. You saw that I did something like 2 days ago when I was teaching you. I did a calculation in one loop, and I also did it in the other loop, and I still got the same answer. I used Kirchoff's law. So now, let me start from the simple circuit you all know. So this is a resistor, and this is your EMF, your battery. Now, if you look at this guy, let me tell you one thing. Look at this. That is just a loop. It's just a circle path. It's just one. Abi, if you look at this thing, this is just a single loop. If I take a rubber band round, that single one is just a single loop. Abi, so this is a single loop. How many loops can I get here? How many loops can I get here? That's where you have to be careful. This is one loop. If I say this is A, B, C, D, E, F. A, B, E, F is a loop. Do you get that? B, C, D, E is a loop. A, C, D, E, F is a loop. If I remove this now, this is a loop. Abi, if I put this is a loop, this is a loop. So there are 3 loops here. You know those kind of games that they will put and they will say that how many triangles can you get in whatever. When you look at it. So for this one, A, B, E, F, this is a loop. So if I close this now, you'll be seeing one loop. Abi? If I close this, you are seeing another loop. If I close this at the center, you're also seeing another loop. That's what we are saying. Do you get that? So there are 3 loops, but don't get too bothered. Now, looking at what I have here, forget about, this is just a symbol of something. How many loops do I have here? 1. Do you get that? Don't say this is a loop. That's just what? A resistor. Is that taking? So now, when you have a loop, according to Kirchoff's law, I want to get the sum of all of the potentials here. You know that there can be work done here. There's a potential drop here that we always calculate as V is equal to IR. Abi, this is also a potential, but this one measures the total potential. Abi, so now let's imagine that this is just the loop we have. Then, according to Kirchoff's, you can take your own loop like this. If you take your own loop like this, there are rules you follow. You can also decide to take your loop like this. There are rules you follow. So what are the rules? First rule. So the rules you apply when you are using Kirchoff's law. The first one made us to know. What did you do? Name. Not group. Low potential. So high potential. Let me put, for simplicity, for a battery, when you are going from negative to positive, that is, the direction of the current is like this. If the direction of the current is like that, whatever your battery is will be given positive. So if you look at this first loop, in what way is my current moving? It's going to move this way because of the loop. So, meaning that whatever I give this guy must be positive. Then secondly, if you notice, it is moving in the opposite direction. Like this is my second loop now. My assumption is that it's moving this way, meaning that my current is going this way. So, current moving this way, your E will be given negative. So when you're moving from low potential, that's the minus side, to high potential, positive side, you are going to use plus. But when you are moving from high potential to low potential, then you use minus. But you don't need, just note this. Now, the second rule of it is that this, for resistor does not have positive parts or negative parts. It is this one that will determine what this one will be. So if this guy is positive, then you are going this way. The positive side for this one, if this place is positive, you know, when you did your physics experiments, then they will tell you that you connect positive to positive, Abby, negative to negative, to those of you that went to good school. So now, this is going to be taken as positive. Negative will be connected to negative. So this is what will determine what this one will be. Is that taken? So for resistor now, if your current is going this way, that means you are going from positive to negative. So this one will be even negative. If it's going this way, that means you are going from negative to positive. So this one will be given positive. That's the second rule. So for the first rule now, depending on what your resistor is, if it is positive, what determines if it's going to be positive or negative? I said, what determines if it's going to be positive or negative? The battery. Abby, it is the battery. So now, if you have discovered that this side is positive, this side is negative, if it's going from positive to negative, then your value of V here is going to be negative. You know that V sub R I'm talking about? That's the voltage drop here, Abby. But if it's going in the opposite direction, the value is going to be positive. So you're going to have positive V sub R. Those are the rules. Then when you now have more than one battery, you will see that soon. That was like what I did yesterday. So for this now, let's do it for the two loops. Then I'll give you a basic example analogy again. So now, for the first loop, you can decide to take it anyhow you like, you will still get the same answer. For the first one, let's say this is I want to do it for that first one. So what will it be? That means I will sum all the potentials together. That means positive E, then plus, and summing all of them. Then this one is the next one, Abby. Will this be positive or negative? Negative, because of the way I'm moving, Abby. So that will be minus V sub R is equal to 0. So sum of all of the potentials in this loop will sum up to be what? 0. That's second law. Now let's apply it. You now see that this will eventually be equal to E minus VR is equal to 0. And E is going to be equal to VR. That is if you neglect internal resistance from what we have been saying. So, for what you have there, for all cases and purposes, whatever the value of the battery is what this one will give us as VR from what we described, from all the stories we have been learning. So, what if I have more than one resistor? If I have two, how will I do it? For the second one, let's do it. So let's take this one for the second one. In that case now, what will my E be? This for the first scenario. For the second scenario, my E will be negative. Abi, what will be the R? That means I will say plus V sub R is equal to 0. Abi, so now I can say that whichever way. I can say V sub R is equal to E. It's the same thing as this. Do you get that? So anyhow you take the loop. Now, I think there was a question we solved. Write this first. So we'll now do example. I'm not going to make it very complicated. And even if you have a complicated form, just know this. Just know this. You will do it when you get to 100 level. And this is the major thing that used to give a lot of people problems. They don't know how to sort this part. And the moment you can't sort this part, you can't get anything. So if you don't know how to assign your signs, you can't get anything. So that's the major problem. But now you know. So I don't expect you to have issues. You will do Kirchoff's law in 100 level. So but these are just a basic circuits. They can give you complicated circuits. You'll now be analyzing them. Let's say I have a circuit like this. This is another important thing you have to note. Now, we did this one. What I did here, you can do it manually. Let's say I have, let me just quickly do an example of the one I just finished doing. You have a circuit like this. They told you that the battery voltage is 12 volts and the resistor, this thing is, let's say is 4 ohms. They now say you determine the currents. They said determine the currents neglecting internal resistance. In this circuit now, you already know what the current will be. You will use your V is equal to IR. Abi, the same battery, since you have neglected internal resistance, that means your current should be around 3 ampere. Abi, do you understand that? This is what we have been doing for a couple of times now. So it should be 3 ampere. So if you use your loop, what will it be? That means it's going to be plus 12. Abi, will it be minus or plus? Minus. You know, this is ohms. That's resistor. What's your VR? IR. Abi, that's your VR. Do you get that? Everything will be equal to what? 0. So you can now say 12 is equal to IR. So 12 is going to be I times 4. Then I is going to be 3 ampere. That's what I analyzed here. But you would remember I gave you a question on this last time. That I think I gave you this one to be like 0.5. And I gave this one to be 2, Abi. And one of you asked me, how do I know which one will I pick? Is can't the 0.5 determine all those stories? You remember? So you know this will be negative, Abi. This will be positive. This will be positive. This will be negative. So if I take my loop this way, then if one of the things you now need to know here is that if your E1 is greater than E2, it is that one that will determine what this one will be. If your E2 is greater than E1, it's what will determine. I'm just trying to get what will be here, positive or negative. So now, but from that one I gave this one to be 2 volts and I gave this one to be 0.5 volts. Meaning that what will drive current around these circuits is actually this one. But you can do it in either directions, you will still get your answer. But if you look at this now, even if I say this is 2 ohms, all you just have to do is say 2 minus 0.5 Abi, then you get 1.5, then say 1.5 is equal to I2, then I will be 1.5 over 2. Those are the things you have been doing. So if you are looking at me like this, that means you have not been reading, and you always have problems. So if what I'm saying now you can't get it, is what we did. This same question is in your notes, not even extra curricular now. So now, from what we have here, if I assume my E1 is greater than E2, then that means I'm going to take my direction this way. Then in that sense now, if I want to apply my rule, so I'm going to have positive E1, Abi, minus, do you agree that this will be minus? Because we're going from positive to negative, minus E2. This is going to be plus and minus. Because why? E1 is positive here. Do you get that? E1 is what determines what is happening in the circuit. Because I already say E1 is greater than E2. So now I can say minus V, that will be equal to 0. Shaded. So I can say E1 minus E2 can be equal to V. So if E1 was 2, E2 was 0.5, then I2. Do you get that? So now, from what we said, let's say this is 2. This is 0.5 volts, this is 2 volts, and this is 2 ohms. I now said determine the current in that circuit. From what I've taught you normally, you can do that. But you just need to know Kirchoff's law for now. Because I'm going to combine the circuits. There was a question in this way post-UTME, I don't know if that question is available. So we use that one to solve it. To just explain. Now, from what we have here, that means that my E1 is going to be what? 2 minus 0.5 is equal to 2I. So I is going to be 1.5 all over 2. That would be 0.75 ampere. We solved that like 2 days ago. But just to tell you what I did that time to get the loop rule. So now, if I'm going the other way around, will I still get the same thing? So let me go this way. So how will it be? So I'm going to have plus E2 Abi minus E1 plus Abi VR. You know why we have to use plus here? Because we already said something that it is E1 that determines, because we have an idea that E1 is greater than E2. They will give you some of these things like clues that you look for. Do you get that? So now that will be equal to 0. At the end of the day, so I can have my E2, and my E2 is what? 0.5 minus 2 plus 2I is equal to 0. Abi? So I can say minus 1.5 equals to minus 2I. Then minus and minus will go, right? So we have I is equal to 1.5 divided by 2. And that will be 0.75 ampere. You can still see that I still have the same answer. All you just have to do is put the necessary directions into consideration. So, if you don't understand what I'm doing here, don't worry, leave it to when you get to 100 level. Leave it to when you get to post-UTME class. We'll do some complicated ones during post-UTME class. And that will not be useful for you when you get to 100 level. But what I've taught you so far, will help you to do most of these calculations normally. We only apply Kirchoff's law when the circuit is so complex, and this circuit is not complex. We only apply it when it is complex. So this circuit is not complex at all. What were you saying? I'm obstructing, sorry. If I have this, all these ones are things you can do normally. R1, R2, E. So if I take my loop this way, this is going to be negative, this is going to be positive, this is going to be positive, this is going to be negative, this is going to be positive, this is going to be negative. She gets, because this is the one that determines. Then if I want to do my Kirchoff's law, what would that be? That's going to be plus E minus V R1, or let me just say V1 minus V2 is equal to, so I can say E is equal to V2 plus V1. She gets, so depending on what it is, I can simplify it to say E is equal to I R2 plus I R1, which means that E is going to be I into R2 plus R1, and that is like saying resistors in series. That we always say that total voltage. We always say total voltage is equal to I R total, and R total for series is always what? R1 plus R2, and the total voltage, that's it, So it's the same thing, you know. But when you apply Kirchoff's law, it's only when, so they can give you a circuit like this and put a lot of batteries, and start telling you to apply Kirchoff's law. That's when you apply Kirchoff's law. When it is very complicated and you look at it like, what will I do here? So you can have battery. So you can have something like this. Then you now start taking the first loop. You just follow those 2 rules I gave you. You take this loop too. Then you take the third loop. That's when you apply Kirchoff's law. If you look at this now, you look at it and like, which of the formulas can I apply here? You can't. You can't apply all these basic formulas to this kind of thing. So that's when Kirchoff's law is useful. It's when the circuit is so complicated that you have to analyze it. So, but you have to just know. So the only thing you now need to know for Kirchoff's law for JAMB is that they can ask you, Kirchoff's second law, what does it state? And that is when I said that the sum of the voltage must be equal to what? 0. That's all you need to know for JAMB. Then the second thing you need to know for JAMB on it is that they will ask you, Kirchoff's second law is also known as what law? Law of conservation of energy. So let's write that. Are you through with the board? Ammeter, before you should stand up. Stand up. You are taking class, you are sleeping. What are you not doing? Your heads are on the table. What are you doing? You are resting. Shall stand up. Your heads are on the table. Oh yeah, stand up, the 3 of you. You are writing, Abby. You are not writing. You to stand up. Stand up, your own head was on the table too. Answer me. I felt you were writing, you, but it's like you two were not even writing. Your head was just on the table. And it seems you are inductively influencing each other. So, right. Are you through with the board? Kirchoff's second law is also known as the law of conservation of energy. Kirchoff's second law is also known as the law of conservation of energy. Law of conservation of energy. So that's what you need to know. Is that taken? What they will ask you in JAMB, they are the two things I've talked about. All these things I'm doing, they will not ask you. But if you know these things I've said now, you will know how important it is to you when you get here. You will know how important it is. But for now, you can go and do the stress when you get to school. So, but you will do it, whether you like it or not. So, can we move on? So, that's where about Kirchoff's law. So, before I talk about applications of electricity now, they cannot see. Should they go to the back? Will you still sleep? Especially you are not sleeping. I understand. There are different types of sleep. There's a sleep that immediately they wake you up, you say, I'm not sleeping. We have REM. So I understand. Oti law, so some of you will just wake up and you open your door and just be going. Wake up, wake up. You're like, I'm still on the bed. Oh, there's a fair day, Lagos. I understand. So sit down. Don't put your heads on the table again. So have you written that? Shoro, you know. Now, let's talk about, I think that's the one I've not talked about, conversion of galvanometer to ammeter. Conversion of galvanometer to ammeter. We've done magnetism, Abi, and you know the function of galvanometer. Galvanometer helps you to detect small currents. It's just to detect small currents. So now that you have this experience and you have the experience of magnetism, then we want to talk about that now. Can I rub the board? So, we already know the topic is conversion of galvanometer to ammeter. Galvanometer to ammeter. Many of these things I do not try to cram. I try to understand what is really going on. And that's why even if I'm teaching it, I might still remember, even if I do not prepare for it. So, you have a galvanometer, and all you know is that your galvanometer only detects small currents. Then your ammeter is the major instrument that helps you to measure currents. Now you have a galvanometer and you want it to do the job of ammeter. So you can convert galvanometer to what? To ammeter. What's the function of a galvanometer? Detects currents, small currents. But ammeter is used to measure the magnitude of current. Do you get that? So now, if I'm to convert, let's say what I have is galvanometer, and this galvanometer, let me make it bigger. So this galvanometer, when current is flowing in a circuit, is going to detect that current. And let's say this is the circuit. So that galvanometer will detect it. But now, if the current is too much, this guy only detects very small current. If the current is too much, there might be an issue with the galvanometer. So now, and I don't have ammeter, so what can I do? I can convert this guy to an ammeter. In order to convert it, so let's say the current that is coming in is like 10 ampere. And 10 ampere will spoil this thing. So now, I don't want the whole 10 ampere to go through it. What can I do? I can plug in a resistor. But that resistor, now look at the way I will plug it. Let's say I plug the resistor here. 10 ampere is what will pass through. Let's say I plug the resistor here. This is the galvanometer. What current will pass through this galvanometer? Because this resistor and the galvanometer are in what? Series. So have I now done what I feel like I want to do? It is still the 10 that will pass. I hope you are following. So now, they can ask you that when you want to convert galvanometer to ammeter, you are going to plug the resistor. That resistor, will it be in series or in parallel? That's why I'm explaining what I'm explaining. Sometimes when you want to read a book and you don't even know how to approach the book, you can go and solve questions first. So let's say you want to read a topic in chemistry now, maybe current electricity, or a topic in biology, maybe transport system. But first, before you start reading, look for questions on transport system. Go through them. You might not understand, but going through them, you will be seeing what they are really asking. Then I'll go and pick the textbook. You will now see that you will understand it better. Compared to someone that first pick the question, they pick the notes, read, and now go and solve question. So by that time, you'll be paying more attention to, because you notice you have seen this thing hard somewhere, then let me know more about it. If I'm coming now and someone outside just tell me that, oh, do you know that there are 3 ladies in your class that are short and yellow? I don't always pay attention to that before. But the moment the person said, do you know there are 3 ladies, I'll be like, I don't even know. When I get to class, what do you think I'll be looking for? 3 ladies that are short and yellow. So I won't take my time to start reading everybody. So you have a note, you have the textbook to read, transport system. Then you go to question first. And the question says that what artery carries oxygen, what artery carries blood from the ventricle to the whole body. Then immediately you see that question, you don't know. But when you start reading transport system and you see how blood is pumped throughout the body, you start looking for that artery. I don't know if you understand my point. So sometimes, what I just did now is that I ask you a question so that you will pay attention to what I'm about to explain. The question is, in JAMB, they will ask you, in the conversion of galvanometer to an ammeter, there will be a resistor plugged. That resistor, should it be in series or in parallel? Let's assume you don't know now. And that's what I'm about to explain. Then I now told you, if I plug this thing in series, will it do the job I want it to do? That means you should know that your answer should be what? In parallel. And let's see why it has to be in parallel. So I will plug that resistor. I will connect it like this. So if I connect this resistor to this guy in parallel, what do you think will happen? As the 10 ampere is coming, when it gets to this junction, what will they do? It will split. Current will go through the galvanometer and current will go through the resistor. Abi? Now, the next question they can now ask you. This resistor you have plugged to this galvanometer, you have gotten the answer that should be parallel. The next question, should it be a high resistance or a low resistance? Think about it though. Should it be high or low? Should it be high or low? So if you process it, some of you are saying high, some of you are saying low. Listen, what do you think? Low. Listen, why do you think it should be low? What can you say? Don't be scared. Don't be nervous. Don't be scared. Whether you say it wrongly or correctly, one of the things about life is confidence. You can speak rubbish in confidence. So everybody, should it be high or low? Low. Low. It should be low. You know your purpose. You know that if this 10 ampere pass through this, it will destroy it, Abby. Then you want to divert everything. But if you make this thing very high, that means the current will not pass through it. The current will have no choice than to pass through this thing. I hope you are getting it. But you know the function of the resistor now? To resist the current. So if the resistor is low, then most of this 10 will find a way to pass. Do you understand my point? So now, that's the first thing we need to know. So right. To convert a galvanometer, there's a code we use to remember it. To convert a galvanometer into ammeter, a low resistor, a low resistor must be connected. You people are lucky that I'm not used to all of you. That's maybe I was not around teaching last year. I would have known all your names. You hear put said on the locker in my class. Sometimes I neglect some of you because I don't really know you. I don't know your name, so and I can only say hey, you hey. That shall do. So I said to convert a galvanometer to ammeter, a low resistor must be connected in parallel. A low resistance resistor must be connected in parallel. This is called shunts. Shanty, hallelujah. So that is called shunts. Is that taken? So to convert a galvanometer to ammeter, you need shunts. And what is shunts? A low resistor connected in parallel. So that's it. All you just need to remember is slab, shunts, ammeter. So when you are converting galvanometer to ammeter, you need a low resistor in parallel, and this means shunt. They can ask you for shunt or multiplier. So if they say shunt, they are talking about this. If they say multiplier, they are talking about another thing. That's what we'll talk about next. So now, from what we have here, the next thing is they can now say you should calculate the value of this resistance. But it's very simple. I don't cram formulas here. This guy has his own resistance. This guy has his own resistance. Because both of them are connected in parallel, you have to understand something. If both of them are connected in parallel, I want to believe we all know by now that they are all going to have the same voltages. Abi? So that means the calculation aspects. That means the voltage across the galvanometer will be equal to the voltage across the resistor. Abi? That resistor, I'm changing it to S to mean shunts. Abi? So I'm changing this one to S. I hope you are following. This is all you need to remember for your intents and purposes. If you feel like you have been following electricity class from beginning, this is all you need to remember. Because a whole lot of us to keep that formula in our brain at times. I don't even know that formula up to now. They say maybe I derive it, I look at it. So let's do it. So there's a formula to calculate these shunts, R and RS. So let's do it. So if I say VG is equal to VS, what's my VG? IG, RG, Abi? That's the resistance of galvanometer multiplied by what? The current flowing through the galvanometer. Are you lost? Eh? Oh yeah, let's do it. Do you understand this? Why did I say VG is equal to VS? Because the resistor and the galvanometer are connected in parallel. Do you agree to that? So now, what is IG? We know that V is equal to IR, Abi. So if I say VG, that means I'm saying current passing through the galvanometer multiplied by what? The resistor of the galvanometer. So I can say that is going to give me IG, RG is equal to IS, RS. I'm looking for RS. That's what they most times ask you to look for in exam. So now, making RS the subject of the formula. RS, one fold, one shepherd, is equal to IG, RG over IS. Now, the formula does not stop there. The reason is that you will know this one, I total. Because if you don't know, then why are you converting? You know it. That's what you want to do. So your formula does not stop here. So they will give you IT. Now, this I total is going to be equal to, according to Kirchoff's first law, the current entry will be equal to what? Current going out. Shady? So now, on this other side, so we're going to have that IT is going to be equal to IG plus IS. So IT is going to be equal to IG plus IS. Do you agree to that? So making IS the subject of the formula. So we are going to have IS is equal to IT minus IG. So if IS is equal to IT minus IG, bring it back to your formula. So I'm going to have R sub S is equal to IG RG all over IT minus IG. So this is the formula they always want you to cram. So this is the formula. They can always ask you, they will give you all of these values and they will say calculate the shunts. Is that taking? So you will see questions on that. But I don't always cram this formula. I just need to understand principles and apply it when it's needed. When you reach to a level, you know that's what you need. For now, it might be looking tough for you, but keep fighting. So all you need to remember is VG is equal to VS. I can derive the rest. Are we together? So the next thing after this is how to convert. Please, who has physics past question? So let me give you a question on it quickly. So, if you open your past question to page 88, remix past question, the question states that number 3, page 88, I'm 100% sure that some of you are writing this down currently and you don't have past question. I'm 100% sure. And if I say it that you will also score above 300, I'm sure that you will join them to say amen. Let's go. Page 88, question 3. So listen, you all have seen it, Abi. In order to convert a galvanometer into an ammeter, a low resistance shunt is connected in parallel. B, a low resistance shunt is connected in series. C, a medium resistance shunt. D, a high resistance E, A. So if you have forgotten, remember slab. It must be low, shake it, and it must be in parallel. Is that taken? Opposite of it is for the one we are about to talk about. As simple as what we just said now, they can still add some people in JAMB and still miss it. Some of you, your problem is attention. You don't just want to pay attention. It's most times when I'm teaching, I most times tell you the things you need to pay attention to. It's just that with time, so man pop. But most times I will tell you, note this, note this, note this, pay attention to this. However, you have so listen to this. You have your past question now. Go here, everybody, look at question 29. It's a waste of time if I have to start dictating the question. It's your past question. So 29, solve it and tell me the answer. And you don't have to just use the formula directly. You can quickly pen it down. They write the formula. Get used to it. Don't be lazy. It takes more energy to cram than to understand it. But before you understand, you will first spend energy. But the moment you understand, it's part of you. But when you cram, you have to cram it forever. And you still forget it. Both of them require energy. But one is a positive energy. One is a negative energy. So solve question 29. Then we'll move on to the next thing. Did I give you the efficiency of a cell? You can see how they place the options. They gave the answer and they also gave parallel and shunt and series and all. So sometimes you can use those ones to eliminate your answer in case time is no longer on your side. Just be smart. Are you done? What's the answer? Option A. What's the A? 5.9 ohms. 5/9 ohms in parallel. Very good. So let's move on. You all should get the answer, man. Who did not get the answer? Dictates the question. So yeah, a galvanometer of resistance 5.0. So the resistance of the galvanometer is 5 ohms. Has a current that flows through it. What's the current? 100 milli. Now 100 milliampere, you have to convert it to ampere. She gets. That's going to be 100 times 10⁻³ ampere. That's the conversion. That's still like saying 0.1 ampere. That's the Ig. Is that taken? What else? So how will it be extended to 1.0? That means how can it be made to measure 1.0? And that would mean that you want to measure high currents now, Abi. This is what it can measure. But now they say, how can you make it to measure something higher? So that means that the resistance must be connected in parallel, Abi, to make it measure higher. So now, how do you do that? What's the I total given? That's 1 ampere. She gets. So if you slot in all of these values here now, you get your answer. She gets. But let me see, if I were to be you, this is what I would have done. I need not cram that formula. I would have just, since I already now connected it in parallel, I would have just said that. And I know that they gave me I total. I would have just said that my Ig is equal to Vs. And I'm going to say Rg is equal to Is Rs. But already know I don't have Rs, Is. So but I know Ig. So I can put Ig 0.1 times Rg 5 is equal to Is. I don't know. I already know Is is going to be I total minus Ig. Abi. Then my Rs is what I'm looking for. She gets. So I don't have to cram the formula. So now I can say that what's my total? 1 minus 0.1 Rs is equal to, is it 0.5? Yes. So now 1 minus 0.1 is what? 0.9 Rs equals to 0.5. Shake. So can you do the rest? The CRS is going to be 0.5. To make your maths easier, you can say 1 divided by. So that's 3A1. So that's 5/9 ohms in parallel. Shake. So that's all. Oh yeah, next one. Conversion of galvanometer to voltmeter. Conversion of galvanometer to voltmeter. Are you there? Conversion of galvanometer to voltmeter. Can we move on? So, you can make, what is the function of voltmeter? What's the function of voltmeter? To measure potential difference, Abi, to measure voltage. What's your name? Aisha. Because it's meant to calculate work done. Ó dẹ̀ wò pé kí ló gbà lọ́wọ́ ẹ̀? Aisha. Èmi gbọ́ nǹkan tó sọ bọ̀ mí sọ̀rọ̀. Ìwọ́dẹ̀ wo lè mọ́júmọ́ látòkè délẹ̀ ọkàn dédé bínú èèyàn. Ẹ̀yin obìnrin lọ. Ọlọ́run mọ ọ̀rọ̀ ẹ̀mí tó ń gbé lòdì. Ẹ̀yin obìnrin ẹ̀mí wo ló ń gbé lòdì? Ó bá mọ ọkùnrin ìdìbò títí. Ẹ̀mí Ọlọ́run ló gbé nílẹ̀ lọ́jọ́ àpò. Àti ilẹ̀ làwọn obìnrin ti like material things. Àti ilẹ̀ láti inú garden of Eden. So if you see a woman now that say that I'm not materialistic, I'm not irọ́ ni o, tètè sá, irọ́ ni. Ìwọ jẹ́ kọ́ fún lápò. Yes, so that's why I didn't say what you said is correct. What you said is correct. So now, what I want is that I want my voltmeter and galvanometer now to do the job of a voltmeter. Help me to measure voltage. So I'm converting galvanometer. So let's make sure that this speaker is here once you wire speaker. Because the way I'm backing it is making it not talk at times. So galvanometer being converted to voltmeter. This one now, let's say I have a potential of like 24 volts and I know my galvanometer cannot carry it. So I've connected the galvanometer but it cannot carry that voltage. It's too much for it. So I need to plug something that will divide it. We usually call something potential divider. Potential divider. So we call something potential divider. So I want to divide this potential in such a way that it cannot measure it. I'm going to connect a resistor. Now let me ask you this question. If I connect a resistor like this, what will be the potential across this resistor? What will be across the galvanometer? So have I divided it? Because they are all in parallel, Abi. Being in parallel to be the same potential. Sure, you are getting it. That means that if you connect it in parallel, you can't achieve your goal. You must connect it in series so that there will be different potentials. Do you get it? And if you want greater work to be done, should this be of low resistance or high resistance? High resistance. If I connect them in series, it's the same current that will flow, Abi. But if I make the resistance very high, that means the potential here will be very high because V is equal to IR. Well, it's not easy to be found. Come again. I'm only saying some stories that will just make you understand it better and not make you to cram too much. If I connect it in series, in parallel like this, what I want is this guy should measure this potential. But he cannot measure it because it's too much. So what do? I need to find a way to divide the potential. That means I need to make sure that there's something that is doing work here and something that is doing work somewhere else. But that resistor I want to connect, if I connect it in parallel, I will not achieve my goal. Because connecting them in parallel means that potential across this will be the same as the potential across this for parallel. VR will be equal to VG. But if I connect it in series, then the potential will be divided. So if I connect them like this is now arrow. There will be work done here from the distance, and there will also be work done across this guy. So the potential across this guy, I can measure it. Let's say the potential across this guy is VG. Then connect it across VG. The potential across this guy, let's call it VR. Then connect it across VR. So now, I've done it in such a way that there will be a potential loss here. And there will also be a potential loss here. I've connected them in series. Now, if this one is reading 14 volts, what will this one read? 10 volts, because I've divided it. I hope you are following. The only way you can divide is when you connect them in series. All this electricity now, they are connected in parallel. So, from what I have here now, I'm now saying something. I'm saying that if I want more potential here than in this place, what do? Do I make this resistance low? Note one thing first, because sometimes when you are solving questions, the question might just ask you something you have never had before. Most of the questions you will see too, especially these days of JAMB, most of you used to cram past questions, and it's not past questions they ask. It's your knowledge they are asking these days. And that's why, if you see, it's not pride, I don't know, aside media side, whenever I'm going to that through that whole UI, I used to see one longer board too in ISI that has a lot of 300 students. 300 plus, there are people that scored 300 plus. I saw one long board too. Aside that, I've not seen. How many tutorials have you seen in Padova up to that long board of result of students? How many tutorials? Do you know any in Ibadan? I only know one in Lagos. Oh yeah, tell me how many? But I'm not happy now, and it's not about maybe primers does this and that, but I'm telling you that sometimes the major reason our students do well is because they understand what is going on. So even when they get to exam hall, they apply their brains. They don't just come to exam hall. They apply their brains. At this point, a whole lot of you don't still know how to apply it yet, which is why you have to work well. You have to work well. Normally, I've been under tutors before too. They will just give you this formula, and they will not explain all these things and explain. They will just give you the formulas, and they will give you questions to solve, and you move on. But when you now see some problems, funniest thing is that your question, this thing I'm saying might not be asked. They might not ask you. But there are some questions that when they ask you, the knowledge here will help you to solve those ones. There are ways in which you now start, because they will ask you a question here, you think about that, you think about this, you think about this, you connect all the dots, and you get your answer. It's not everything that is just V is equal to IR. It's not everything. But apply your senses to when you're solving them. So let's go back. So I'm now saying something. You have to think. I said something. I said if I want a high potential here, I want this one to be the one that will help me to carry more of the potential. You know, it's because this one cannot carry it
That's why I'm dividing it. Abi, if I want this one to help me carry more, what do you think I should do to the resistance? Should I have a high resistance or a low resistance? And how did you know it's high resistance? That's where I'm coming from. How did you know it should be high? Who can genuinely explain that? Don't hide your head. I will not call you. Who can explain that? Why do you think this one should be high in a genuine way? What do you think? Yes, my love. Royal Majesty. God bless you. God bless you. That's why I'm giving church. Because the current in the circuits is constant for both of them, Abi, and we already know that V here is equal to IR, and V here is also equal to IR. So the only thing I need to change to increase this is like saying V is directly related to R, Abi. So if this guy that is flowing, because both of them are in series, what is flowing through this is what is flowing through this. So in order to increase this potential now, what do I need to do? I need to increase R. So if I increase R, the potential here will be more. For this one now, if it has a low R, then the potential here will be less. So the higher the R, the more the potential drop, the more the work you have to do across it. Because it's resisting the flow of electron. So when you increase that resistance, then you have to do extra work to push those electrons forward. So at the end of the day now, that means that to convert a galvanometer to a voltmeter, we need to connect what? A resistor in series. And that resistor must have what? A high resistance. I leave the rest to God's hand. Emmanuel. Yeah. The one we did. Yeah. Yes, so that the galvanometer will be the one. The thing is that, you know, the way we connected that one was in parallel. You mean some of you will be laughing as if you know it. We have this galvanometer here. We have this resistor here. Abi. So I said, when the current gets here to divide, if the resistance here is very high, this guy would not. It's more like, look at this door and look at that door. The two passages we have, they are these two doors. If we leave the two open, where do you think people will want to take the most? Here. But now we blocked this place. Do you have a choice? Where will you go? That place. So now in this case now, if we block this place, that's why we are increasing the resistance so that current will not flow. Then the current has two alternatives. Then it will go this way. That's why we have to decrease it so that more of the current can pass here. It's like opening the bigger door. But in this case now, if the current is coming, does he have an option? If it passes through the galvanometer, it will come out and it will pass through the resistor. Shake it. So the current that will flow through both of them is the same. So it's not the resistance we are now saying that okay, if the resistance is high, current will still pass. But the only thing is that extra work will be done so that that same amount of current is passing. That's just the thing, because the electrons are flowing. Let me say 3 electrons are coming. This is a series. Three electrons are coming from here. When they get here, they want to pass through this guy. Now, you need to do work to move them across this guy. But when you are doing the work, there are a lot of resistance that don't want them to move. But you still want them to move because they don't have any choice of where to go. If they no matter. That means that you will find a way to push them with force. That means you are going to do extra work. But if you leave spaces, they will just pass easily. I hope you are getting it. So now, from this scenario now, you will do extra work, extra push. But now, let's you now overcome that push. Then the three of them now pass. How many will still pass through this? Three. When they get here and the space here is so free, do you have to do extra work here? No. Then they will just pass and they continue. But if you have provided extra work in this place now, as they are coming, let's say the three, they are getting here. The moment they get here, they have two options. Some can go here, some can go here. When they get here, and you say, you say, and I know I need to meet at the back, and they will go back, and they will not pass here. Do you get the difference? So that is the thing. So we are increasing this resistance because we know that the same current is what is flowing. So if we increase the resistance, extra work will have to be done here. So this 24 volts, we do work more here than here. So if it does more work here, that means that you might spend 15 volts here and just spend 9 volts here. Do you get the difference? That's what we are saying. So, right. So let's write on that. So convert a galvanometer into a voltmeter. So convert a galvanometer into a voltmeter in order to measure a high potential. So convert a galvanometer into a voltmeter in order to measure a high potential. In order to measure a high potential. A high resistance resistor, open a bracket, multiplier, we call it multiplier. A high resistance resistor, so you open a bracket, call it multiplier. A high resistance resistor, close the bracket, multiplier, must be connected in series. Must be connected in series to the galvanometer. Must be connected in series to the galvanometer. Are you there? Alright. So, we have talked about that. So we call that multiplier. It's just, please, is opposite of that first one. That first one is low resistance. This one is high resistance. So when you remember slab for that first one, just know the opposite of slab is for this one. Do you get that? But we call that one shunt. What do we call this one? Multiplier. Show you there. So let's solve question on it. So how do you do the calculation here? You have seen it. It's in here. The total voltage I want you to measure, let me call it V sub T. That's the total potential. Then what I want to divide it to VR and what? And VG. That means V total will be equal to what? VR plus VG. That's what you need to know. So V total is going to be V sub G plus V sub M. I'm calling it V sub M now, meaning multiplier, Abi, and that's for the resistor. Do you understand what I did here? So leave your V total because that's what you know. That's what you want to divide. But you just need a resistor that can help you divide it. Show you. So now you can say V total is going to be IG, RG, Abi, that's the resistor of this one, multiplied by the current of this one, plus, this is all you need to just remember, as long as you understand electricity. You don't need to cram the formula, but let's give you the formula to cram if you're a learner. So, that will be IM, RM, Abi, But remember one thing, Ig and Im are the same. Do you agree? It is the same current that is going through that this battery is supplying, that goes through the galvanometer and that's also go through the multiplier. So I can now say that Vt is equal to Ig or I, so to say, into, don't let me put Rg and let me just make Rn the subject of the formula. So, okay, Rg plus Rn, Abi. So I can say Vt over It minus Rg is equal to Rn. Vt over It minus Rg is equal to Rn. Do we agree to that formula? That's it. So if they say calculate the multiplier, this is the formula you will use. But just learn this. Let's look for a question on that so that you quickly solve. We have to finish electricity before you go for a break. We are not supposed to waste time, but I'm taking it so easy with you. And you should be happy. And some of you God said, you should be happy because if I want to finish this topic, the whole topic in 1 hour, I can finish it in 1 hour. But all this being slow, the right me something, no, you are really enjoying. So open to the same page, page 88. Page 88. This one does not have diagram though. Fat sources. Who has fat sources? Is that fat sources? No remix. I want to see if this one has diagram. Okay, this one has diagram. This question 18 is the same thing, but this one does not have the diagram. So this one has the diagram. So question 18, remix. Is also question 18 here. Is that taken? So let me help you draw the diagram for this everybody. If you have remix with you, page 88, question 18. If you have fat sources, page 111, question 18. So you have to calculate the value of the series resistance required to convert the above galvanometer into a voltmeter full range deflection of 15 volts. So in this question now, you are looking for R. There's 5 ohm under the level, but that's what I'm looking for. I'm already thinking about where is the resistance for this. So you can see that if you just apply this formula now, you get Abi, you are given the total voltage, Abi, and you are given the total current. and you're given the resistance of the galvanometer. Don't make mistake to go and say VT minus RG over IT. You will get the wrong answer. It is VT over IT minus. Do you get that? I think there are two different things. If you say VT minus RG over IT, that would be wrong. But this is VT over IT, then minus R. That's why I have to put that bracket. Minus RG is equal to RM. So they say you should look for RM. That's this one. So let's say I were to be you and I do not want to cram the formula. What can I do? I just, from here now, I can see from the diagram myself, so I don't need to cram formula. I can see that these guys are in series, and I know that the potential here will be divided. So I'll know that this 15 will be equal to this times this, equal to this times this, and that's all. Let me show you what I just said. You know how to solve it now. So from here now I can go on. This is 15, Abby. VG is what? IG, RG, Abby. So I can say 5 times 0.0 plus VM is what? IM, RM, and my I is the same. Get. So that would be 0.015 RM. Then you solve. When you solve this, then you subtract it from this, then you divide it from that. And that's all. So yeah, sometimes I don't know why I find it hard to cram this formula. During the time I was learning for JAMB, it was so hard for me to cram this formula, and that's for that one. So I did not bother. So I just learned the principle properly and I applied what I did. So now let's talk about electrical energy and power. So I won't waste time. Electrical energy and power. Efficiency of a cell. Let's define efficiency of a cell. Can I? Oh yeah. Are you still writing? Oh yeah, sorry. Right. Question 23, page 88, remix. It should be in fact success too, page 111. There? There's no diagram here too. Question 23. Oh. There's supposed to be diagram here. There's diagram in fast success. So I think fast success is better than remix. So question 23 says that in the circuit shown in the figure T. So where's the circuit? Where's the T? Gashi. number or lower? Okay. So let's look at question 23. Everybody, I'm not writing on the board. Let me draw the diagram for those that have readings. And those that could afford readings but could not afford fast sources. Lord, my dear, calling me to go on by different sources. So, those that have been remixed, look up. Don't worry, remix came before fast success. And it's normal. Fast success could have even used remix to do his own, but now corrects one or two things from remix. Now remix is seen as the problem now. That's why you should always go out to not to judge. If you do something after me and you do not do it better, if you become a physics teacher and you do not teach the physics better than me, you are a very terrible student. But if anybody now sees you teaching physics better than me, and they now say they prefer that person than me, then that means you are still a very useless person. Because you have lost the part that the student must know more than the teacher. So remix came before fast sources. Fast sources could have used remix questions to do his own. But now when he's doing it, he will now do it better. Then now you discard remix because you feel fast sources as, when you are now going around and say fast sources is better than remix. And fast sources did his own when there were no AI tools. AI tools that can edit for you. I mean, remix did his own when there was no AI tools. So don't judge people. We learned when there was no Google. When there was Google, but there was no nothing. We learned when there was nothing like all these apps to practice. That's when we learned. We learned when all we had, the only option we had was textbook. There was no YouTube for us. There was nothing. It is whatever our teacher says in class and what we read extensively on our own. Then I had different sites. I was learning chemistry. Whose book is this? Okay, you can read it. I had this, there's a site called Free Online Chemistry. That's where I used to go and study chemistry. Then there's another site, kind something. I used to know those sites then. That's why I used to study chemistry. They are for white people. Then, because Ababi Oyemi, but the teacher then so Oyemi. So I went further. I was just interested because then highest in our exam used to be biology. If you see anybody pass very well in science class, the person score like 80-something biology. We are always scoring like 60-something chemistry physics. Before you see someone, these days everybody is scoring 90 chemistry physics. In our generation, if you see someone score 70 in chemistry physics, my physics I had 73. I had 70-something too. If you see 90 that year, the girl that had the highest in my class, she had 60, then she now had 80-something in biology. And those days, I used to dislike biology. I was so much interested in chemistry and physics during my JAMB class. I wanted to know why people were having problems with it in class. So I was reading, I was doing everything to read it. And that's why all the generation that now follow me, it's easier for them. Physics is easier, chemistry is easier. They will not know the ojú títí báyìí mọ́tò bá fẹ́ gbá mi màmá ka chemistry lọ lójú títí. Omo, it was worse. But you people are enjoying now. I could remember the topics that my teacher taught me in chemistry. Most of the topics we have to go and read. And in my secondary school, they will give you about you to go and write the whole notes. But then the next class, when I had big year back, my annoying life. Ẹ̀ka ló máa ya ṣòkòtò ẹ̀ kò ṣe é rí. Káṣà máa dúpẹ́ kó lẹ́yìn mú lọ́fẹ̀ẹ́ lófò. So when you get to a level, that's why you see sometimes when you do a book and someone is snapping or putting a copy of it on the phone. There was a time I think when I first gave one of these books, that I now saw that one boy was selling online and he was telling everybody 200 naira. When I started that my chemistry textbook in 2010, I bought, there was this book, I bought it that time. So the idea, all these remix, before they started doing them, I swear to God, there was no remix, there was no, we used to buy all these unique, there's all these normal past questions those days. So those ones, they will compile all the questions year by year, so it's not set. So then I will just be thinking about it. Because if we finish a class, I'll be selecting questions from 1978 to, I'll now be writing them out. I'll now be like, can't I do a book that has all of these topics? Then I'll talk to my friend, I'll talk to everybody around that. We can do this, do this. Then I now bought the book. Then there was no all this computer to quickly get things. So I will now be writing. So every question was documentary from 1978 to that year. I was writing them out. So when I'm done writing everything, I'll now start solving everything one by one. So that when I've done the manuscript, I'll now give a typewriter. So that when we type everything, then I'll produce the book. But that thing was taking me years. At that same time, I was working on the chemistry textbook, the physical chemistry, that some of you used. I was typing those ones. So there were now errors. I did not know how to write equations. It was a lot of, that's why I don't always leave campus. So when I now enter OAU, if everybody go home, I will always go and sit down with that book and be writing. Till I got to Ibadan in 2017 or 2018. I got to Ibadan. So that book I still kept on. When I first started tutorial, I brought it there. People used to use it. And Peter used it and book. Then later, I just saw that there's a book called Remix. And that book, it was just like the person stole my idea entirely. Someone was faster than me. And that was how that one gone. But when I now produced that physical chemistry that I started printing, then I just saw one boy online. That's why I used to tell my students that if I give you a book and I'm thinking about you so that you'll be successful, the biology I've done to some extent now that I've given all of you to use. All the notes, everything I've taught you, I've done them in the textbook. But because of things of the past that have been happening to me time to time, that's why I'm keeping so many things now to myself. So immediately I gave the textbook out. I just saw one boy just put his name. Just say textbook for sale. The funniest thing is that you are now selling that textbook online. Then we used to sell it around 1,500-2,000 as the textbook. Then I saw textbook for sale 200 naira. Me fẹ́ mo kọ́kọ́ fẹ́ wọ DME kí n ṣe pè fún pé So when you are snapping people's book, you don't know the stress of writing those books, but you just carry it. And that's why we always say that by the time you have put a lot of sweat, sleepless nights into something, this thing is a crime. Oh. If they see you snap a book and they arrest you, it's a serious crime. Serious crime. Some of my lecturers fought on campus that they were even about to send one person away, all because of plagiarism. If you are writing any book and they see something that belongs to someone, it has a trace in your own, and the person has now sue you, it's a serious crime. Past questions are still normal. Past questions, you are the one that will produce your solution, it's still okay. But some things that someone has sweat, the same way he wrote his solution, it's what you are said go, Nippon will be here. By the time they sue you, especially if the person already has ISBN and everything. Those my textbooks, I have ISBN for them. So if one day I trace it out, say, oh my God, sue him! Definitely 2 portions of rice in Agodi. So, but always think about people's efforts. So what I'm just saying here is about this book. You might feel like this one is better, but look at the time it was produced. Remix was far better than all those unique we used to use. Those unique those days, out of 50 questions, 20 can be wrong. 20 questions will be wrong. But these days now, remix produced and it was better than that one. But now, this one, any book you produce tomorrow now should be better than this. Does that mean that this one's efforts? Do you know the number of lives this one would have helped? So, if they say that don't judge people, don't judge things, there's a reason for that. You will only judge based on how opened your eyes are. You only judge. And it's over cooking, they know to back in taking for personal, no matter how you are. God is your strength. Just continue. So, the question here gives you this diagram, and this is definitely a resistor, but they are trying to pass an information there. So they said, in the circuit shown in the figure 4, C is the resistor whose resistance falls as temperature increases. For a resistor, if you increase temperature, what will happen to the resistance? It's for a resistor, it will not decrease. So increasing temperature normally increases resistance for a conductor, but for all those semiconductors, increasing temperature decreases resistance. It's in your notes. I gave it to you when we started. Go and look at factors that affect resistance when I gave you. What's the effect of temperature? Go and check it. What did I say? Abishen Rod Moso. Go and check it because I don't expect some of you to be saying what you're saying. Don't forget about this question now. This question might just want to put something. The higher the temperature, the higher the resistance, because those electrons just going, they will not flow. So don't forget that. So forget what this question is saying for now. Is that taking? So this question says that the resistance falls as temperature increases. That's what the filler is saying. So, but that's one of the things. If I'm doing a textbook, I will never say that. They said that probably I don't have time. You are not supposed to say that resistance falls, and I already know this is a resistor. If I increase temperature, resistance is supposed to increase. But now this book just said it. I can work with what it has said, and I will move on to get my answer. That's why your mind should not be restricted. But the logic here is not correct. That's just the relation. So can we move on? So now, they now said that in the circuit shown in the figure 4, C is a resistor whose resistance falls as temperature increases. L1 and L2 are lamps, so they are lamps. Assuming the cell And this could have been correct too if that is assumed to be probably an incandescent lamp or a diode. It's something that it is negative temperature coefficient, all those things when you do semiconductor, so that can be true too. So assuming the cell has negligible internal resistance, as the temperature of T increases, what will happen to it? So option A, let me ask you, as temperature T increases here, they already told us something. That as temperature increases, what happens to the resistance? It falls, Abi. So if the resistance is falling, what do you think will happen to this guy? Will the brightness increase, remains the same, or decrease? It will increase. Because now there will be more current flowing, Abi, so it will get brighter. Do you get that? For this one, will the brightness increase or decrease? For this one, why? This one is taking most of it. This one, what? The thing is that there is current flowing here. There is electron flowing. The only thing is that the way these guys are connected, they are connected in parallel. The voltage here is the same voltage here. And it is the voltage that determines. You will say you have low voltage or high voltage. Shake it. So not low current or high current. It is the work you are doing here. But the fact that you change the resistance here doesn't mean that it affects the work you are doing here. It does not affect it. So the brightness of this one remains what? Constant. It does not change. The only one that will be affected is this one. Because as you are decreasing resistance, the voltage will be dropping or increasing. Do you get that point? So what is affecting this now is this resistance connected to this. So this one can get brighter if this one drops, and it can get dimmer if the voltage drops. Do you get that? So if the resistance increases and voltage drops, then this one will get dimmer. But for this one, nothing is affecting it. It remains the same. That's why the way our light is connected, although this one it's more like a series connection. If you off the lights now, everything will go off. All the bulbs will go off. Abi? But in your house, if the way it's connected in your house, you switch off one bulb, it does not mean that the other bulb will now go brighter because you switch one off. I don't know if you're getting it. That one will remain what it is. Except if they are now connected in series, the moment you switch one off, every other thing goes off. Because it's the same thing that is flowing through all of them. But if they are connected in parallel, if I disconnect this now, this will go off. Abi, this will still remain on. Do you get that? That means whatever is happening to this has no effects on this. That's what we are saying. Whenever they are connected in parallel. I'll tell you about home appliances soon. So this one goes brighter, this one remains constant. That's the answer. So the electrician that works here, I don't know. Well, it's because of what we need it for. Imagine that in your house, there's a switch that controls your TV, your bulbs, your refrigerator, your warmer. What's that one called? Microwave. Now, your mommy is in the kitchen microwaving your food. Your daddy is sitting down watching BBC, watching how US killed the Iranian. Now, and you, because you know to say you want to off lights. So all of a sudden you just go to your bulb, and your daddy feels, let party monologue. Your dad should not be like my daddy. Your daddy also. Your mom should just come out. Talo pano. Because of the light to switch off, what you shake, because mommy shake kitchen. See the that there, just pack your load and leave the house immediately. So that's why most of your appliances at home, they are connected in parallel. So when you do switch one, it does not affect what the other is doing. But if they are all connected in series, the moment you switch one, it will off everything. So if you see something like this, it's an error in connection. But they might have done it because it just felt like the rates at which the power of a cell is converted to external use. The power of a cell, the rate at which the power of a cell is converted to external use. So efficiency is usually equal to, although it's supposed to be output power, and be equal to output power, which is I over input power, i.e. times 100. V is the external, and I can go. And what is my V? Do you agree? What is my E? I into R plus R multiplied by 1. So I and I can go. Then efficiency is going to be capital R over R plus R times 100. So from what we have, we can say that efficiency is equal to R over R plus R multiplied by 100. So they can ask you to calculate the efficiency of the cell. The efficiency of the cell is equal to this. So you know the capital R, you know the small r, and you get the efficiency of conversion. Energy and power. What is energy? Energy is the fan. The woman suntil, cohesive, hour, man, 350, 360, 370. Overall best in JAMB. Please, I'm looking forward to that overall best in JAMB. I'm looking forward to it too, because I cannot wait. Go to that one. I can't wait. Go that for any 20-something million. Go to 5 million there. I mean 10 million. But I can't wait to. I'm always dreaming of that every time. Problem then here. I like but I trust the person that will be the overall best. That will more what I want to more. But trust or motto more. Ocean sweat. Funniest thing is that when they invited that girl on national TV, when they invited that girl like 2 years ago, They gave one 16 million naira. Then when they invited her on national TV to talk to her about being the overall highest, how she did it and everything, she was just talking about it. She used to read 6 hours a day. She read from SS1. She did this. She never mentioned one teacher like this. Yeah. No, it's common. It's not, you people can say, you forget some things easily. You forget some things easily. It's not your fault. It's probably the way your brain has been streamlined. You cannot, not even to say, it's just like the same way. First thing is to give thanks to God. Appreciate God for everything. It's God that made you come across teachers. It's God that give you brain. It's God that give you everything. Then appreciate your school if it's in secondary school. That's a stage for you to bring your school to 9 lights. Appreciate your school. My school really did well. Most especially Mr. Ola, my physics teacher, and Dr. Samuel, Dr. Ife, and you mentioned them. Everybody. When you mention them, then you now talk about, after these teachers have taught me and go, and they really push me, and you mention some of your friends too. You appreciate people. You don't just let the effort be as if they didn't even do anything. And some of you have to hype yourself. The day I knew that most of us, Iyatoman Jewa, was when, was he AIT, which newspaper, Punch newspaper called me that year. I still have the number. That was like during the GD sets. I still have the newspaper. It should be in our draft. Then they just called me from Punch newspaper. I posted the results of most of them, Jola, Moji, GD, everybody, Prince. I posted their results on Twitter. Then Punch newspaper called me and were like, because that year maybe people feel somehow. So they were like, how did we do it? That can they talk to those students? Can I give them access to talk to those students? I said, why not? Then I called those students that Punch newspaper will call you, interview and all. You don't know how life is going and all. Then I sent all their contacts to Punch and they called all of them to interact with them. And next publication of paper, all their faces came out on the newspaper and their names and their results and everything. They now wrote the son of a fish seller. If you remember, that's what they wrote for GD. Oh yeah, ledger, score 300. Just they do that to sell their papers. Look at that my friend now that graduated from UI, that best graduated, I say cobbler, shoemaker. A shoemaker became the best graduating student in UI. Like they would share out something so that you to reveal that oh, she did shoemaker. So they get best graduating students. This is part of the things you two would have said while they are interviewing you. But they will not pick that word. So if you say that I never had a dad, because if we ask you, you will tell them your challenges and everything. And all of them, I'm not sure, I think I showed in the paper too. But most of the conversation, the guy messaged me now told me that they are sorry for some sake and all of those things. The name of the school might not be published. Like primers, they might not say anything about primers. And no. I said, number one is that me, my advice is Aliko Dava Omoye. I told him, I said, I don't care. The name of the school, you shall bring them out. See, there's a way people can help them. And all of those things. And in the conversation, there was no place that they mentioned that the tutorial they went to was primers that year. But there was a section for me too. That my picture was there and they just talked about me some bits. That's all. You know why they wouldn't have put my name? Because they expected that if they would help me promote my school, I should come and pay. and they are using my own students to promote their papers. So the thing is that I still have that paper. So the thing about life is that we that want to impart life, our tibakamu, or the teacher one, but we have to learn to show the act of gratitude too. There are sometimes that when some of my students come around, they would have forgotten many things that you have done for them. When they start talking, I'll just be looking at some that I remember the beginning. But it is life. That's what life is. Everybody learns to, especially when you are there, you want to prove yourself that I did it myself. The emotion for this and that. So it's normal. But please learn the art of gratitude. God appreciates gratitude. God appreciates it. There are some people that I know 247, even for the fact that they are almost finishing in medicine. There was a time I was talking to one of my students in UK that studied medicine, and I was trying to call her to come and help me talk to the students, and she said that she said there's nothing she will say to all these students that I've not said. I said, but sometimes they believe in someone in UK than someone that is telling them now. All I'm saying, some of you can have to be under, but by the time I say the last event we had that year now, during this guy's set, that I invited all my friends abroad. I called a friend from US, I called one from Canada, then I called one from Europe. Then to talk to our students. You needed to see the joy in the face of students. Everybody was so happy. So they would rather listen to someone that is looking like the person is made, not the person that made them. That's like we are that back we don't, but sometimes you have to open your mind. That sometimes learn the art of gratitude. It's you people that will be able to sacrifice for. There are sometimes that when we come here, we stand morning to night. If we complain that you are tired, we say no, we will continue, we will do it. But at the stage, it's affecting our health little by little. And that's why we are reducing some things one way or the other. So, but always appreciate people in your life. When people help you, especially some of your friends that are even always there for you, don't be a baramoleje. We were taught like that. Don't be. There are some people that helped me when I was growing up. I do not forget them. I always have a diary where I always write their names. Then when I start working every month, I will pick one person in a month. I'll send something to the person. I'll pick another person the next month. If na 20K I get, about 20K. If na 20K I get, about 20K. You fit see am say, okay, this dollar, check about 20K. You know I'm not Nigerian. So don't be. So a cell delivers. If it's a question you can solve, I will not answer it too, because some of you can just waste people's time. A cell delivers a current of 0.2 ampere through a resistor of 10 ohms. When the resistor is changed to CSO, the current delivered is 0.8 ampere. The internal resistance of the cell is. Now, you might not be able to solve this. I understand that. But it used to come out in your JAMB and 57. Now, let's analyze it and see how we solve it. Whenever they are comparing two things in your calculations, just always look for something that is common to them so that you can equate them. The body moves at this distance. This one moves at this distance. If the acceleration of this one is equal to this one, that acceleration is equal. You're looking for it so that you can equate whatever you can equate. Here now, they said delivers the current of, I don't know if this is 0.2, the person they write it well. There's a cell let's say this is the cell. The cell delivers a current of 0.2 ampere. Please look up, bro. This is a common question that most people don't always know how to solve. Most people don't know how to solve it. I had some issues with it when I started learning too, before I knew how to solve it. And it came out in my UI post-it here. It used to come out in JAMB too. It's a common thing. So this cell, this is the battery, is delivering a current of 0.2 ampere through a resistor of 10 ohms. So now there's a resistor. The resistor is 10 ohms. The manual of Galvanometer. They now said the resistor is changed to 6 ohms. Did they change the battery? But they changed what? The resistor. So they changed the resistor to 6 ohms.
But with the same, do you think it's still the same current
that will flow? Is it still the same current that will flow? Because the resistor has reduced. So now, they now said the resistor is changed to 6 ohms. The current delivered is now 0.3 ampere. 0.3 ampere. Then they said the internal resistance of the cell. This cell has an internal resistance, which is the same. When you see something like this, they are just giving you two conditions so that you can equate them under the same value. For this one now, you know that if for this one is going to be equal to I there's a wire burning somewhere. Can you smell it? Don't plug anything on most of those sockets by the wall for any reason. Please, please. Don't plug anything in most of those sockets by the wall. Please. But something is burning somewhere. So, tomato cutting remind my why I'm cutting Jolon. So now, this is for this one. Let's put the values. So we are going to have E is equal to 0.2 R times 10 plus I. You don't know that, Abby? So normally I can call this equation 1, but let me just be doing it side by side so that you don't get lost. Oh yeah, let's do for this one. For the second one, we have E is equal, but we don't know the E. But we know that this E and this E are the same. So let me call this X. So EX, let me call this one EY. So at the end of the day, this is going to be 0.3 times 6 plus 0.3 R. Abby, that's EX. I can now say that my EY is the same as my EX. So I can say EX is equal to EY. What's my EX? 0.3 times 6 is what? Abby, plus 0.3 R equals EY. So times 10, 0.2 times 10, that's 2, plus 0.2 R. She gets, the rest is mathematics. So you can say 0.3 R minus 0.2 R equals 2 minus 1.8. That will be 0.1 R is equal to 0.2. Abby, R is equal to 0.2 divided by, that's what. So I don't know who gave the question, but do you understand now? Yes. Sometimes, whenever you are solving a question, and you realize that they are comparing two things, just look for something that is common to them. That thing that is common to them equates them. That will get you what you want. Do you get that? What is common to these guys now? E. Then I equated the E's. That's how you solve problems. If they want to make life tough, that's what they used to do. But if you want to make your own life simple, look for what is common to them. And that's all. Is that okay? So the time is you will be doing applications later. Please be time conscious. So it's because I know you are almost through with the syllabus. There's nothing much left to cover. Abi, we have done magnetism, we have done electricity, we have done waves and lights. Abi, and then on the mechanics, we have done motion. What else have you done? You have done friction. You have done equilibrium of forces. You are doing pressure now, Abi, with Ms. Kola. Which other one? You are on density and upthrust. So the topics you have left are not that much. Have you done gravitational field? So what is now left? You only need simple machine. Have you done work energy and power?
Yes.
That's the Paris syllabus. So you are left with simple machine and elasticity and atomic physics and simple AC circuits and electronics. So please, if someone call Ura, what is it? So let's find a way to quickly cover this before the end of March. So that we know what to do. Please. That 28, Samuel, and you coordinate by find a way to make sure that it's married everything before that 28. So that we go for March. Then on the 20th to what do you call it? So please, what's left in biology? They are just the systems, Sabi. You should have finished organic chemistry too. Okudia. So there's nothing much again. Please work out.